Hello students, welcome back to our live series of live sessions on atomic structure brought to you by Tutoratti. Hello, if you can hear me and see me, please say hi. I'm waiting for you. Just tell me your name so that we can interact in a better way. Say hi. At least greet me. Hello. Good evening. Good evening, Sarthak. So you are here. We are waiting for more persons so that they all can join and we can continue this session afterwards. Hello. If you have missed the last session, you can go to Tutoratti JEE channel and revise that chapter because it was the beginning and it was very important to build your basics. Hello Jayant. Oh, it's good to see you again. It's very good. Hello, we'll wait for 1 or 2 minutes so that all can join. Good evening, sir. Okay, till the others are joining, let's revise what we studied yesterday. Yesterday, we studied what is atom, what is the Thompson's atomic model, and all the theories which Thompson put forward, and I told you that I have no hand in it. Swear to God, I have no hand in it. We just, we can say, negate all the theories of Dalton, and then what else we saw? We studied the discovery of electron, how it was done with the help of cathode ray experiment, and the discovery of proton, which was done with the help of anode ray experiment, and also the discovery of neutron, which was done by Chadwick. Okay, what is the charge of electron? If you guys can tell me, please tell me, what is the charge of electron? Yes, Naivika, it is negative, but what is the value? What is the value? And tell me, is the charge of electron actually negative? I told you yesterday, I gave a hint. Tell me. Okay, I told you yesterday that it is out of convention we have taken electrons charge as negative and protons charge as positive. They are not actually negative or positive, they are just opposite of each other. Okay, but we are on the same page. That we have revised, we have done all the homework and we are ready for today's session. Are we not? Yes, electron were discovered by J.J. Thompson. And proton was discovered by, can you guys tell me, who discovered proton? I told you specifically yesterday. Jayant, you need to be sure. Question mark shows lack of confidence. Okay. I mean, capital letters doesn't show confidence. Dalton discovered none of the particles. Electron was discovered by J.J. Thompson and proton was discovered by Goldstein. E. Goldstein discovered the proton and neutron was discovered by, just today itself I have told you that neutron was discovered by Chadwick. James Chadwick, by the reaction of beryllium plus helium. Carbon atom was produced and a neutron was ejected out in that reaction. So today we are going to study about the atomic number and mass number and these two chunnu-munnus, isotopes and isobars. In yesterday's session also we studied about, at least I mentioned isotope and isobars and you guys replied what are isotopes and what are isobars. So we are going to actually see the definition and all in today's session. Okay, let's start from first. What is atomic number and what is mass number? Atomic number is represented by Z, not A, not M, Z. Atomic number is represented by Z and mass number is represented by A. How can I know then what is the atomic number of an atom? Atomic number can be found by the number of protons present in the atom. And where is the proton present actually inside the atom? Can you tell me? Is it outside nucleus or inside nucleus? Proton is present outside nucleus or inside nucleus? Please tell me. And don't tell me out of the earth. It is there, but outside. Where? खंडाला में? नहीं निका? That is the question actually, and it is good that you are here because we today will discuss and get the result that where is this proton present actually. Let me give you a hint. It is present inside the nucleus. This is the answer actually. So yes, don't be alarmed. Proton and neutron are present inside the nucleus and electron is outside. And we are going to know that by the experiments that how exactly did we find it. So number of protons actually describe what is the atomic number. Number of protons present inside the nucleus tell us about the atomic number. Suppose if an atom has only one proton inside the nucleus, then the atomic number is going to be 1. Which is that atom? Can you tell me? Which has only one proton in it. And only proton. Because it will have atomic number 1 and that will be, yes, it will be hydrogen atom. Okay, so number of proton, but the equation says Z is equal to number of proton is equal to number of electron. Is it true? Is it true always? Number of proton and number of electrons is equal to atomic number? No, it is true only for a neutral atom. It is true only for neutral atom. If I am looking at a charged atom, it is not going to be equal to atomic number. Because if I look at H positive ion, it has 0 electrons, so atomic number can't be 0. ना डब्बा बना दोगे उसको? नहीं, वो 0 नहीं है. It will be 1 because we will. Yes, Kishore, it is actually hydrogen. Yes, so if I have to find out the atomic number of an atom, I will look at the proton, which is more appropriate. Okay, if I have to find A is what? Mass number. mass number is described by A, which is sum of proton and sum of neutrons. If I add number of protons and number of neutrons inside a nucleus, I am going to get the mass number. Now, I can say in brief that atomic number Z is equal to number of proton is equal to number of electrons in a neutral atom, and the mass number as number of proton plus number of neutron. Now, if I have given you the mass number and the number of protons, can you calculate neutron for me? दो सर ये तो आउट ऑफ सिलेबस हो गया, ऐसी बात मत करो. Only I have to shift it, take it to other side, and you will get neutron is equal to A minus P. What is that? Is atomic mass. If I remove number of protons from atomic mass, I am going to get number of neutrons in that atom. Can you tell me number of neutrons present in hydrogen atom? Hydrogen atom has only one proton in it, and its atomic number is 1. And what is its atomic mass number or mass number? It is also 1. So how many number of neutrons are going to be there? It will be 0. The mass number, yes Nainika, it is quite correct. The number of neutrons are going to be 0. So all in all, if you see such type of symbol, it means A, X and Y. It means this is the element, X is the atomic number and Y is going to be the mass number. On the below side, you write atomic number, and on the above side, you write mass number. Now, don't get confused. This mass number can also be written at this place. In some books, it will be written as this place. So, don't be confused. Just the below will be the atomic number and above will be the mass number. And you can differentiate it very easily because the below number is always going to be equal to the above or less than it. So you will know always that mass number is always either equal to atomic number or greater than the atomic number. Okay? So let's move on to the next thing. What are isotopes? No, I'm not going to tell you. You will tell me. What are isotopes? Yesterday also I told you. अब yes, tell me. Exactly. Jayant has told exact definition and Nainika has told partially correct definition. Elements with same atomic number, those are going to be isotope, but they also need to have different mass number. I told you yesterday that a JEE question came in 2019, hydrogen, deuterium and tritium. Remember? अगर नहीं है तो शंख पुष्पी पीने लगना अब, ठीक है? कल ही बताया था, याद होना चाहिए अब तो, ठीक? Elements with same atomic number and different mass number. Atomic number should be same, but mass number should be different. That those elements will be isotopes due to difference of number of neutrons. Number of neutrons will be different. Okay. Now let's move on to the example. Here, chlorine 35 and chlorine 37. Generally, if you look at, you will read it as chlorine 35 and chlorine 37 because the atomic number is going to be same, but the mass number will be different, and we describe it from mass numbers. I will say this is chlorine 35, this is chlorine 37, uranium 235 and uranium 238. Both of these are isotopes. Now, can you tell me why is it important to know about isotope? Can you tell me? Why is it important? मुझे क्या जानना है? क्या मिलेगा मुझे इससे? बताओ. they might have different reaction. मेडल मिलना चाहिए किड को. They might have different reaction. They will have different reaction. Exactly. Let me tell you an example. If you keep uranium-238 in your pocket, no problem. No problem. If you keep uranium-235, सरकार ले जाएगी जेल में. आया कहां से आखिर? और ऊपर से जब तक सरकार ले जाएगी उसके पहले नहीं अपनी हालत खराब हो चुकी होगी उसके पहले, क्योंकि दैट इज रेडियो एक्टिव. और रेडियो एक्टिव है तो नहीं, मैडम क्यूरी याद होंगी ना. हाँ, शी गॉट कैंसर from radium, but that was also radioactive, and uranium-235 was also radioactive. So be careful. अगर हो तो लेके मत घूमना जेब में, ठीक है, घर पे रखना सेफ. Next, let's move on to how I'm going to get. अब important बात ये है, if chlorine is also present as 35 and chlorine is also present as 37, how am I going to know the atomic mass or mass number of the chlorine atom? Because I know you are very smart kids. You already know that chlorine has an mass number of, it has an atomic mass of, can you guys tell me what is the mass number of chlorine or atomic mass of chlorine? Comment. What is the mass number of chlorine? Tell me. At least get a hint. It should be between those or outside those और रूम के बाहर और आपके बैग में कहां. What should be the number? 0, -1, infinity, double delta. Kids, it should be, yes, Jayant, you are a little correct. It should be between 35 and 37. 36 is quite close to it actually. How will we calculate? It should be between 35 and 37. Yes, Nanika, it is quite right. It should be between 35 and 37 because they both have a part to play in it. It's atomic mass. So how will we calculate atomic mass? We will calculate it as the percentage of one isotope multiplied by the mass number. I'm repeating again. Percentage multiplied by mass number plus percentage of other into its mass number. And yes, you have googled correctly. It is 35.5. It is 35.5. हाँ, चीटिंग किया है नहीं किया. ओके, आई बिलीव यू. सो it is going to be 35.5. Now look at the question. Is there any difference between atomic mass and mass number? Atomic mass and mass number, I am using it very frequently, either atomic mass or mass number. Is there any difference? Is there any difference? Yes, there is difference. Atomic mass you must have seen as 35.5 as evident from just now, and as what you can say, iron, it is 53 point something. It means it can be in the points also, but mass number will always be a whole number. It will be 1, 2, 3 because mass number is number of proton plus number of neutrons. और आधा प्रोटॉन और आधा न्यूट्रॉन भाजी मार्केट में तो मिलता नहीं है. तुम्हें मिल रहा हो तो पता नहीं, ले आओ भाई, मुझे नहीं मिलता. तो मास नंबर will always be a whole number, but atomic mass can be fractional as well. Okay, example you can see. It is, I have told you earlier also, protium, deuterium and tritium. Okay, it is radioactive. हाँ, खतरनाक. आगे isotopes के examples, as here we can see, this is oxygen 18 which is used in, it is radioactive. It can be used in the reaction mechanism. To how to trace it, how to trace a particular reaction, this oxygen 18 is used. You will get to know in more in about this in organic chemistry. Okay, and this is carbon 14. It is used in, can anybody tell me where carbon 14 is used? To know about the age. किसकी एज? मेरी नहीं, मुझे पता है, मेरे पास सर्टिफिकेट हैं. It is used in carbon dating. About the how to know the dates or age of a particular fossil or a tree can be, yes, we can calculate that age from this carbon 14. Okay, now मैं नहीं बताऊंगा. You will tell me what are isobars. Yes, Sarthak. I'm very happy that you remember something. कुछ तो याद है. Tell me what are isobars. Tell me guys, what are isobars? What are isobars? Okay. Elements with same mass number. Did I say mass number? What is mass number? What is mass number? Just a while back I have told you mass number. What is mass number? Number of proton plus number of neutrons. Yes. Same mass number, different atomic number. Such elements will be called isobars. Examples. Yes, yesterday also we talked about this when we were disproving Dalton's theory. जब डाल्टन को कह रहे थे अपन कि भाई अब अपना टाइम है, तो ये argon and calcium both has mass number of 40 and atomic number, they have different atomic numbers. That is why they are isobars. Let's move to isotones. No, I said isotones, not stones. Isotones. हमने बराबर कर दिए number of proton. We have also equated number of proton plus neutron. What is left? What is left? Equate number of neutrons. We have equated number of protons. We have equated number of proton plus neutron. Now equate number of neutrons. Same number of neutron. The elements in which same number of neutrons are present are called isotones. Exactly. Sarthak, you are quite right. Calcium 20, 40. How many number of neutrons are present in calcium? It is 40 minus 20, it is 20. In chlorine 37, chlorine, the isotope 37. How many number of neutrons are present? 37 minus 17, that is 20 again. So these are isotones. Same number of neutron present, those species will be called isotones. You can take a look at different examples: sodium, magnesium and all. We have equated proton, those will be isotopes. We have equated number of proton plus neutron, those will be isobars. We have equated number of neutrons, those are isotones. And now we will equate number of electrons, and those will be called isoelectronic species. Isoelectronic species, iso means same, electronic means same number of electrons, those will be called isoelectronic species. And isoelectronic species can be of, yes, all these are isoelectronic because oxygen has 8 electrons. I have added 2 more, 2 more. So there will be 10 electrons. Fluorine has 9 electrons. I have added 1 more. तो फिर yes, fluorine wants 1 electron. Why? Because the octet will not be complete. the octet of fluorine will not be complete because it has 7 electrons. I have given 1 electron, it will happily accept the electron and be, उसको मोक्ष प्राप्त हो जाएगा वो लेके, ठीक. Then neon has also 10 electron. Sodium 1 positive, 10 electron. Magnesium 10 electron. Aluminium 10 electron. All are isoelectronic species. These are number of protons, but number of electrons are going to be same. Okay. Some more examples of isoelectronic species. You can check all these examples. The number of electrons are going to be same. That is 18, 18, 18, 18, 18, 18. Take a look at it. These are all now 18. Okay. Let's move ahead. अभी तक बात हुई है कि atomic number क्या होता है. Why I told you about atomic number and all? Because at first you need to know how to write the atom. ये क्या हिंदी आती नहीं है, हम ग्रंथ लिखने चले हैं, कहां से होगा? नहीं ना. At least you should know how to write the atom, then know about what are the different models of atom. See, initially we didn't know how atom look like, because when we see at things, we just look at things, nothing new. How can we see the atom? It is very minute. So scientists have tried so many things to explain how an atom looks like. The first attempt was done by Thompson's atomic model. It is called Thompson's atomic model. What Thompson's atomic model is, it is called, can you guys tell me what Thompson's atomic model is called? Because you must have studied it in class 9th. Yes, it is Thompson's plum pudding model. What else can we call it? Comment and tell me what else this Thompson's model is called. Tell me. Plum pudding is one thing. कैसी जीभ लप आई क्या? प्लम पुडिंग देख के Yes, Jayan. Quite right. It is also called watermelon model. You get imaginary dairy milk. Yes, Sarthak. It is written here, Sarthak. Tell me something more. Plum. What else other than plum pudding? It is also called watermelon model, as Jayan told us. It is also called raisin pudding model, chocolate chip cookie model, apple pie model, so many things. भूख लग रही है. Control उदय. आगे चलते हैं अपन. This model, what was this model? Thompson just out of nowhere just told us that atom looks like this. A circular pie type or cookie type or watermelon type. If you slice the watermelon and look at it, you don't have to eat it. Just look at it. Just look at it. The seeds of the watermelon are positive charge and the entire space, actually the seeds will be the electrons and the entire space will be the protons. This positive charge is spread throughout. The red part of the watermelon is positively charged and the electrons are the seeds of watermelon. He told us out of nowhere. I don't know. पता नहीं किसी दिन सपने में आया होगा शायद. अब ऐसा नहीं है कि this model is rubbish. I know it has 0.0000001 resemblance to the actual atomic model, but it has one achievement that Thompson told us about the neutrality of atom. But other than that, there was no good thing about this model. Why? Because there were limitations. What were those limitations? Limitations were that it was theoretical. If all the experiments that were done on it after by Rutherford, by Niels Bohr and all those scientists, none of the experiment could predict that this is the atomic model. Okay, no experiment could prove that this is the atomic model. Now, the one student, Rutherford, he was actually the student of Thompson. He was actually in the belief that whatever my teacher has taught me is correct. And he was trying to prove that it is the actual model. Okay. And he designed an experiment to prove that the model of atom looks exactly like how Thompson has told us. But he got shocked. Shock laga. कैसे? Initially, Rutherford's alpha particle experiment, alpha scattering experiment, what he did was, let's look at the apparatus. Initially, he took the lead cavity. In the lead cavity, he placed, yes, we can say, Sarthak, that it was hypothetical. Exactly, it was hypothetical. Thompson had no basis for the atomic model, not at all. See, now Rutherford's alpha scattering experiment, he placed a radioactive material inside the lead cavity. Now, why radioactive material? Because that material is going to give alpha particles. Alpha scattering experiment hai na, naam bata raha hai. Alpha particles are going to come out of the lead cavity, and we have placed a circular zinc ZNS screen. Why ZNS? Because the charged particles are going to come out, and yesterday I told you that whenever a charged particle hits a ZNS screen, it glows. Jadoo. The next thing happened, from the lead cavity, the alpha particles started coming out, and he placed a thin gold foil. Rutherford's experiment is also called the gold foil experiment because he placed a thin gold foil. हाँ समझ रहा हूँ, काफी महंगा रहा होगा, चुरा लेते तुम लोग होते तो, है ना? नहीं ऐसी हरकतें नहीं प्लीज, है ना? Lead cavity, he placed a radioactive material. Why lead only? It is for shining. Please, for shining. He could see the experiment. Lead cavity, the lead cavity was there because it was a radioactive material, and as we know, radioactive material is very harmful. जेब में रख के घूमने की चीज नहीं है, ठीक? That is why lead cavity is there, because lead will not let the harmful radiations go out of it. Okay? Why gold foil? In some of the slides, we are going to get the answer of this question, that why he used gold foil. नहीं, अमीर था, show off करना था, ऐसी बात नहीं है. There was a reason, proper reason behind it. Okay? So, it was a source of alpha particle. अल्फा पार्टिकल ये ऐसे करके अल्फा पार्टिकल जूम सीधे पहुंचे गोल्ड फॉइल पे. उसके बाद क्या हुआ? उसके बाद सारे के सारे निकल गए. अब यहां पर रदरफोर्ड चौंक गए, बिकॉज he expected, as his teacher told him, that if it is a atom and it is full and you are bombarding some particles, those particles will be deflected in these directions. But the alpha particles passed the gold foil. He was actually shocked, and he was even more shocked when he saw the other results. What were the other results? Some of the particles were deflected, but he was expecting more, that most of the particles will be scattered in these direction, not this direction. Okay. Very few particles deflected. Just beyond his imagination, one more thing happened. What was that thing? Yes, very few particles. It means 1 out of 12,000 particles actually trace their path back. This 180 degree means they trace their path back. गोली मारी, वापस आके मुझे लगी. He actually explained it like that he explained the result like as if I have shot a bullet at a paper and it has traced its path back to me. He explained this experiment in those words, give or take. Okay, now some of the particles, as I told you, trace their path back. Now, what were the observations? Observations were like most of the alpha particles went through, they passed, okay, and most of the particles passed. Next thing, some of the particles got deflected, thode bahut, there were very few, and 1 in every 12,000 traced its path back, just like this, almost 180-degree retracing its path back. Now, on the basis of these, he proposed his own model. But before that, he explained it that why he used gold. He was not only rich, he used it for a purpose. Why? Because gold is heavy. And because as I told you, initially he was expecting that all the particles are going to be deflected by gold. So if he would have used lighter metal, it would not have produced that much effect. He used gold because it is malleable, it is very malleable. It means it can produce a single atom sheet also from gold. At least he expected. मिला नहीं तो क्या हुआ, ठीक. उसने कोशिश की कि कम से कम एक एटम की शीट बनाऊं, उसको 1000 एटम के आसपास की मिली, ऐसा कहते हैं, ठीक. That is why he used malleable, as thin sheet can be produced from gold. And when the gold has atomic mass greater than 200, so when alpha particle hit it, they are not going to be deflected. They are going to be deflected by a large angle as he expected, but the results were very shocking. As I already told you, results were very shocking. Aluminum is a light metal, that is why he couldn't use it. So deflection. Next thing, what were the conclusions drawn from his experiments? First thing, most of the particle went through the atom, went through the gold foil. It means 2 and 2 4, कोई ज्यादा लॉजिक नहीं लगता है, बहुत क्या ब्रिलियंट माइंड नहीं चाहिए, बहुत भाई क्रॉस करके चले गए. इट मींस क्या? मोस्ट ऑफ द स्पेस इन एटम इज एम्प्टी. द सेकेंड थिंग, positive charge of alpha particle getting repelled by the charge of atom. It means some few of the alpha particles got deflected, and alpha particle has positive charge. It means atom has a positive charge and at a very small place. That is why it is being deflected at a very small angle, and very few particles are being deflected. The next thing, that charge also, that positive charge is concentrated at a very small place, and in the entire positive charge is present at a one place. How can we say that? Because then only the positive charge which is going in the direction, the entire positive charge will repel it. If it had been scattered, it would not have traced its path back. Okay, these were the 3 conclusions drawn out of the experiment, and on these conclusions he gave his own model. And the radius of atom and nucleus, see, by these comparisons you can see that what is the size of nucleus and what is the size of atom. If I just give you a random example, if you place a cricket ball inside a football stadium, this is how the comparison is. The nucleus is your cricket ball and the entire football stadium is your atom, radius of the atom. This is how the difference between the nucleus, size of nucleus and size of atom. Okay. Then he gave us the his own model. He could tell, Sarthak, he could tell that the positive charge was at center because none of the particles were being deflected at a large angle. The one angle that was large enough was 180. It means it has to be in the center by the same logic. In Rutherford's atomic model, on the basis of observations, he told us that the nucleus is present. There is a nucleus in the atom which is present at the center of the atom. Okay, and the electron which is present, that is also inside the atom but not in the nucleus. Electron is outside the nucleus and it revolves the nucleus just like the planets revolve around the sun. घूमे जाते हैं. Okay, but there were some inconsistencies with this model. At least he told us that there is a nucleus that we got to know for the first time. That atom has a nucleus, Rutherford told us. Okay, and the electron revolve around it just like the planets revolve around the sun. Okay, now electron revolve around it, but there were some inconsistencies regarding this. What were those? It is also called solar system model, which is not. Let me tell you one thing. This model is also not very correct. It just told us about the nucleus, nothing else. Nothing else is true about it. So you just need to understand that Rutherford model, Rutherford told us about that atom has nucleus. What were the problem regarding this? The problems were, let's see, what were the problems? And those were the same things that I told you, the comparisons, the radius of the nucleus and radius of the atom, we can compare it actually mathematically. How? Place the volume of the nucleus and volume of the atom, and we can actually calculate that the variation or the ratio between the volume of nucleus and volume of atom is 10 to the power minus 15 by 1. And I have told you the imagination type. You can see, just देख सकते हो कि भाई आखिर क्रिकेट बॉल और फुटबॉल स्टेडियम का क्या कंपैरिजन है. वैसा ही होता है कि इतना खाली स्पेस है, too much space. Okay, the problems were, first thing, it is called planetary model. अब इसके साथ दिक्कत ये है, yes सार्थक, Maxwell theory told us about the drawbacks of Rutherford's model. Yes, electrons are revolving around the nucleus. See, if it is moving around the nucleus, it means they are constantly changing its velocity. The electrons are accelerating. And if a charged particle accelerates, according to Maxwell's theory, whenever a charged particle accelerates, it loses its energy or radiates energy. And if electron is radiating energy, the electron is eventually going to, yes, collapse in the nucleus. How? It will eventually collapse. How will it collapse? Just like this. It will collapse. I know. गलत नहीं हूं मैं. Okay, if it is accelerating continuously, it will radiate its energy, and if it is losing the energy, then eventually by following a spiral path, the electron is going to collide inside the nucleus. And by Heisenberg's uncertainty principle, we know that electron cannot reside inside the nucleus. Heisenberg's uncertainty principle, वो हम देखेंगे आगे. In the upcoming sessions, we will also get to know about the Heisenberg principle. But at least, मेरी बात मान लो, इतना भरोसा करो कि electron cannot reside inside a nucleus. Okay. So the drawbacks were, as I already told you, that electron is revolving as Rutherford said. But if electron is revolving, it will accelerate, and accelerating electron will radiate the energy, and if it will radiate the energy, eventually it will drop inside the nucleus. So that is why this model was rejected, and just like this, the electron is going to, let me show you once again. The electron will follow the spiral path and go inside the nucleus, and this cannot happen because electron is revolving, and that is why we know that so many reactions happen. अगर इलेक्ट्रॉन गिर जाता न्यूक्लियस में तो दुनिया थम जाती, कोई थम सा गया है, वैसा वाला थम जाता, एक्चुअली कुछ नहीं होता. So today we know that there is more to atomic model than this, and those things we will get to know in the upcoming sessions. आज के टाइम में सिर्फ इतना, we got to know about the atomic mass, atomic number, Thompson's model and Rutherford's model. सिर्फ मॉडल नहीं जाने, उनकी कमियां भी जानी कि क्यों वो मॉडल फेल हुए हैं. ओके, नाउ इन द अपकमिंग सेशंस वी आर गोइंग टू नो अबाउट बोयर्स मॉडल and how it will come in the JEE exam and NEET exams. The questions directly come from Bohr's model, and this also. Okay, so stay tuned for the upcoming sessions. It will be on the Monday, so make sure to like, share and subscribe the channel, Tutoratti JEE, and stay tuned, and thank you.